So full disclosure, I'm not a mathematician, I'm a computer scientist. And so what I want to talk about briefly, I'm going to try to keep it brief because the following session, I think it will be more interesting. One of the aspects of this program is to actually, and that's what I want to do, I want to emphasize one of the aspects, which is research projects on this intersection of AI and mathematics. And so just to give you an overview of the program, so the main components are these 3 symposia. In between, we will have these individual talks. And now that we had the first panel, what we wanted to do is to encourage you to, consider thinking about where you want to take the experiences that you're going to get from this program, and what do you want to get out of that. To that end, even though this is the first program, we wanted to encourage you to start thinking about, we wanted to, first of all, motivate you to start thinking about, research directions and, ideally research projects. And mainly for faculty, we wanted to encourage actual collaboration between faculty in mathematics and other computational areas. And so again, the reason why we want to do this is because that's one of the goals of the program. Okay, so to do that, what I wanted to do is to basically try to answer this question: where are things standing in terms of research projects on AI tools and mathematics? And so what I did here is what I'm showing you are actually a number of publications indexed by Google Scholar that contain the keywords AI tools and mathematics. And so what I did is really simple. I went on to Google Scholar, and for each of the years, starting from 2010, I basically got the number of publications that contain these keywords. And so what we see here is basically 4 segments or 4 regimes. So the first one going all the way to 2017, it's this area where we actually have a very low and flat activity. And then that is followed by 2 accelerating periods. So one is between 2017 and 2020. The other one is from 2020 to 2022. And finally, what we see is this actual full-blown explosion of publications. And so, interestingly enough, when we look at the actual timeline of LLMs, what we see is basically a really nice alignment. And so that can easily enable us to basically put labels just from an LLM perspective and LLM timeline, and also their adoption. And so what we see here is we have this pre-LLM period. And it's not that there weren't any publications there. I think on average there are like 150 publications. And when you look at it from like an AI perspective, what's dominant in that period are these symbolic systems and also these classical machine learning approaches. So there isn't really any natural way for mathematicians to interact with AI. Then we have this first acceleration period, and there it's basically the introduction of the transformer, the attention is all you need, that was funny paper in 2017, followed by BERT, and then we have GPT-2. And so what's sort of significant about this period is that neural approaches for solving mathematical problems started to appear thanks to many algorithmic approaches, but the transformers turned out to kind of yield state-of-the-art there, not just on this task, but for many other tasks. And so then what we see is this period that I've labeled as usable LLMs. It's basically a period where researchers started to realize that actually they can frame mathematical problems using natural language. And so that's sort of like, I think it's important in mathematics to be able to do this kind of a natural language type of interaction with an AI system. And so that's one thing that kind of marks this period. And another thing is that people started to realize that, starting from GPT-3, they started to realize that they actually can have some sort of an interaction, and therefore they can think of these systems as something that can serve as their assistants during research, right? Because you sort of like interact with natural language, you send the query and you get some, you do a prompt and you get a response. And so then what we see here, what I think makes this sort of like a full-blown expansion or explosion is the widespread adoption, the availability of these LLMs, starting with ChatGPT and then Claude and Gemini and all of them. And another thing that I think it's worth mentioning here is the type of interaction that they offer, which is sort of like this dialogue-based type of an interaction. And so this isn't really surprising because we already know that LLMs do actually, one of the biggest contributors in advancing AI tools for mathematics. But what I think, at least for me, the main takeaway here is that, this explosion, just if we keep things at an LLM level without diving into sort of like these other machine learning domains that were sort of like integrated into LLMs, like in reinforcement learning, I think the main takeaway is that this explosion is not really driven by sort of like new ideas in terms of LLMs, but it's, I think, my opinion is that's mainly driven by the adoption, the availability of these tools. And so the actual question is like, where are things heading, right? Like where things might go going forward. And so what I wanted to do is I wanted to bring up this recent statement that Geoffrey Hinton made on this question of AI and math. And so, to him, in his opinion, AI will get much better at mathematics than humans, maybe in the 10 years or so. And so this doesn't mean, my point here, the point of bringing this up is to really motivate you to thinking about research directions and research projects. It's not meant to be sort of like an alarmist thing, right? It's not meant to, give you any worry in terms of like, your job as mathematicians or anything like that. Mainly strictly to motivate you to be thinking about research projects and research directions, sort of like framing framing the kinds of questions and opportunities that may come out of this going forward as these LLMs continue to evolve. Okay, so lastly, what I want to do is I want to mention, how are things standing, where are things in terms of research projects, research programs actually, on this intersection of AI tools and mathematics. So what I want to highlight are 4 recent and ongoing projects or programs. And so what I'm going to do is briefly, I've prepared like a slide or 2 for each of these programs. I want to briefly mention the main ideas behind these programs, which we pretty much already know what they are, right? Advancing math research. That's the umbrella idea. So just mention some of the main ideas here and what kind of topics do they focus on, okay? Just to give you a flavor of what's out there right now. So first one that I want to mention is Renaissance Philanthropy. I guess Renaissance Technologies is behind this. I'm not sure. Oh, it's a separate? Okay, sorry. And so it's called AI for Math Fund. Again, the program goal really sort of like general from a mathematical perspective, advance the pace and impact of math discovery. It focuses on these 3 topics. This is Renaissance Technologies. So this one focuses on formal verification and more specifically focuses on developing these open source reliability here is the keyword, AI-based formal, tools for formal verification. It also focuses on data set creation. So the idea is to create these large, reliable, but also diverse set of data sets to train and evaluate these AI approaches, and then also to make these tools more ergonomic, because adoption here is the keyword, right? And so this is a program that was announced in January 2025, and so far they've awarded 29 projects, and actually one of the projects is from 2 faculty here in the CS department at Columbia. You can take a look at the awarded projects for you to get a sense as to, again, to get a flavor of the research activities. The next one that I want to talk about, which actually made me curious about this whole domain. That's how I actually got to know Ivan, by I stumbled upon this the announcement of this program. So it's a program led by DARPA, exponentiating mathematics, and it has a very bold goal, which is to completely transform the way mathematics is being performed by mathematicians. Okay, and so the idea, again, not to be an alarmist here, the idea is not to completely replace the mathematician, but to actually provide a mathematician with a co-author, with an AI-based co-author, which is capable of sort of like generating, producing, and then proving useful abstractions. And so what it focuses on are these three things, which is auto-decomposition, auto-formalization, and auto-informalization. They're not worried about creating data sets, but what they want to do is they want to create this AI co-author, which would be at a level of a professional mathematician. And to do that, what they want to do is they want to do these extensive evaluations, and the evaluations, they would like to do them on a level which is grade level mathematics and above, also advanced level, and also research papers. And what's interesting here on the evaluation side is that they want to do this sort of like a machine learning style of an evaluation, something that's commonly widely used in machine learning, which is cross-validation. And so the idea is that you have a set of proofs, set of lemmas for a proof, and what if you take randomly take some of these lemmas and put them aside, and then let the AI co-author basically recreate them, right? And so that's a fairly bold goal. What's interesting about this program also is that there are two types of teams that you can participate in. You can't get involved in both. So the first type is basically the team that will, the set of teams that will do the automation. And then the other team is a team specifically, specific goal is to perform the actual evaluation. And again, across all of these programs, you'll see that the requirement is to have a really strong multidisciplinary team where like the knowledge will be complemented on both sides, from the mathematician side, but also from a computational scientist side. Deadline was last year, and I don't think they've still announced the actual winners. So lastly, what I want to talk about is the most recent ones. They are both from NSF. So the first one is the AI Mink program. And again, the umbrella goal here is to just advance research in mathematics. In this case, it has a broad set of topics. And so I've sort of like listed them here. Starting with creating these AI tools for conjecture, proof, and verification, also interactive theorem provers. They also have, as one of the topics they want to focus on, is basically developing a training data. So training data seems to be something that everyone is interested in, and it kind of makes sense, right? Because for all of these approaches, semi-supervised, supervised, you do really need to have a training data and also to have a test data. And also what's also interesting here is that they want to see sort of like progress on the other side. And so in this case, they want to see sort of like this, incorporating logic, mathematical reasoning, and compositionality into the AI. In terms of the actual research structure, they're seeking teams. They were seeking teams because the deadline is today. So very convenient for me to talk about this program. So they want to see research teams that bring basically they again complement each other. So it's not like computational scientists are just sort of like giving this support to mathematicians. They want to see progress being made in both fields. Substantial collaborative contributions across disciplines. And so the last one that I want to talk about is one that's deadline is later this year. And so this is actually the only one out of the four where actually the research is done in the opposite direction. So all previous three were basically, develop AI tools for mathematics. Here, the idea is, well, how can we advance, how can we sort of like, there is always a need for AI to advance. There is this really important need to sort of like deepen the mathematical foundations and to also create a strong theoretical understanding of AI. And so that's what the goal of this project is. I think that's pretty much it. Well, I don't really know that many details of the program. It's scale in terms of like the number of. I'm not sure actually. I think you have a fairly big. Yeah, I think it's 3 years, and yeah. Sorry, 6 million across. Yeah, that's the pool, right? Okay. Yeah. So to circle back, these are two of the goals of the program. And so again, early on, we wanted to motivate you to think about research directions and projects. And more importantly, again, to kind of encourage faculty across different disciplines to start collaborations. And so to that end, what we wanted to do initially now, because we are just at the beginning of the semester in the program, we wanted to kind of get your feedback, sort of like we wanted to create a very simple mechanism through which we can get your feedback in terms of your interest in doing research projects and doing research collaboration. So if you're interested, drop us an email, and then our plan is, depending on the interest, to if there is enough interest, we may organize something formal, sort of like a research projects workshop at the end of the program. But at the very least, we'll try to sort of like connect you with faculty or maybe help you sort of like shape up the project. I think that's pretty much it.
Kriste.